For ETDRs, electronic theses, dissertations, and reports, the graduate student authors often create visuals to communicate their research and findings. These may include diagrams, drawings, and illustrations, photos, data plots, maps, scans such as from documents, screen grabs, video stills, and mixed composite visuals, among others. To be clear, tables are considered separate from figures. These are addressed in another video. In general, the images may be raster ones, with images that are created with pixels or picture elements, or less commonly vector ones with shapes and lines and other elements drawn using equations. The first type is in more common usage than scalar vector graphics. To enlarge the first type, there have to be more pixels in the initial image acquisition or capture, or there have to be additional pixels interpolated by an image editing tool. For vector graphics, these can scale up or down without any problems because the shapes and lines and points are drawn on a Cartesian plane in 1, 2, or 3 or more dimensions, right? So to illustrate the idea of image resolution, I'm going to show you the issue using online images. So here I'm in Google search, in the image search for information technology, and these are all considered thumbnail images. When we download them, most of these will come out in a very small format. So as a comparison, I went to information technology in Wikipedia, and I'm going to go ahead and look at this computer logic board. I'm going to go to more details, and I want to show you differences in image size, right? So this one, the 312 by 240 pixels, is the smallest here. I'm going to go ahead and download a version of this. I'm going to save image as, and then just save it by whatever the name is already given to it. Then I'm going to go to the largest available one on Wikipedia, and I'm going to say save image as, and this one I'm going to just call this large. Okay, so I'm going to open up Adobe Photoshop 2021. I'm going to go ahead and open the first image, which is 25 kilobytes. The other one is more than 10 times larger at 270, or about a little bit, almost 10 times. And then what we're going to see here is the image. And if I hold down Control and I zoom in, what you're going to see is that this image has pixelated. These little boxes of different colors, hues and saturation, shade, are picture images. These are pixels. And together they create the image. Now, you do not want an image to do what it's doing here, which is pixelating or breaking apart into little boxes. What you optimally want is a more smooth surface. And if we had text in this image, if we had very low resolution the way we have it here, the words would potentially not be readable. The text and the numbers would alias, right? So they would stair step. And so if we look at the size of this image, the resolution is 72 pixels per inch. Per the documentation, for the ETDRs, we need at least 350 pixels per inch or dots per inch. And then the size of the image also matters. This is only 4.3 inches by 3.3 inches. So this means that not only will this be a low-res image, less than a third of what is needed in terms of spatial resolution, but the size, if we were to try to enlarge this image inside the ETDR, would also add more noise and blur and visual problems to the image. So I'm going to go ahead and say close. I'm going to open the larger one, and we're going to look at this image size. The resolution is a lot higher, and the width and the height are a little bit bigger. I haven't changed the size at all, but I'm going to go ahead and hit Control++, and we see a lot more interesting visual detail, even as we can see some pixelation, right? But we see much more interesting texture. There's actually some words that we can see here from this label. We have better perception of color, high reflectance, texture, materiality, and other features. So one option that we have, if we have a pretty good, initial image, we can say image size and we can jump the resolution. If I wanted to, I could jump it to say 700. Let's say I could jump the size of the width to be bigger, and because I have the width and the height connected, the aspect ratio will not be stretched. That means the relationship between the width and the height will remain the same. And then I'm going to go ahead and click OK. Now this is asking the software program to go ahead and guess at additional pixels and to put those additional pixels in. So this image size is going to be a lot larger, the resolution is going to be better, the text will be more readable, and so on. But depending on the type of image it is, we could have introduced some sorts of visual errors because we're asking a machine to guess. So optimally, we would go with an original high-res photo capture of this logic board at the very beginning. So I'm going to go ahead and save as, and I'm just going to call this a test file. These are JPEG images, which tend to already be small and tend to be lossy. Ideally, we would try to go with a PNG or a .tiff or something less lossy. We see that with our added pixels, the size of our test file is a lot bigger than the two original files. But it is better actually to have a higher res image than a lower res one if you're going to be inputting any of these digital visuals into your ETDR. So this is just something to basically think about. For those who are using Windows, if you do not have an image editing tool, there are some reputable free ones that can be downloaded. And then on a Mac, there is the Preview app that can be used to jump the resolution. Another very common solution that people go for is they go into, they use PowerPoint, and they use PowerPoint to draw various diagrams. So they will take PowerPoint, have a blank slide, they'll put in various figures and labels, and then if they set up their PowerPoint correctly, they can actually output a high-res image, with 500 dpi. So you would, you could go here and you would save out, if we were to browse and go to the desktop, and let's call this presentation. You can actually save as, browse, and in the drop down, save out your slide as a JPEG, a GIF, a PNG file, a TIFF, and you can have it come out in high res. So these are just some things to consider, but there are a fair amount of options for students when outputting high res images.